If you're taking the square root of a number, you're asking yourself, if I was going to square some other number to get the one that I have, what number would I have to square to get the value that I have? The square root of a number is another number which becomes your number when you square it. For example, if I wanted to ask myself, what is the square root of 9? I'm asking myself the question, what number becomes 9 when you square it? In other words, I'm asking myself the question, if I took a number and raised it to the power 2, and I wanted the result to be 9, what number would I have to square to get 9 as the answer? Now, looking at a times table can give you a really nice way to calculate square roots by hand, because in a times table, all of the squares are located on the diagonal. Here I have 1 times 1, then I have 2 times 2, 2 squared, then 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. All of the squared numbers are located along the diagonal of a times table. And the specific square that I'm interested in, 9, I can see is the result of multiplying 3 by itself. 3 squared is equal to 9. Because of that, I would say that the square root of 9 is 3. The square root of 9 is 3. I could also say I'm interested in what is the square root of 49. Not 9, but 49. I'm going to go into my times table and I'm going to look for a number which becomes 49 when I square it. And it looks like the number 7 becomes 49 when you multiply 7 by itself. So the square root of 49 is 7 because 7 squared became 49. So, put another way, the square and the square root have a sort of parent-child relationship. You know, my mom's name is Kim, and so I could say something like, Kim is the mother of Sam. And I could also say something like, Sam is the child of Kim. So there's a sort of parent-child relationship here, right? If I'm saying that Kim is my parent, it would be the same as saying that I am her child. And it's the same kind of thing happening here between the square and the square root. I could say that 49 is what you get when you square 7. 49 is the square of 7. And I could just as well say that 7 is the square root of 49. 7 and 49 have the same kind of relationship as I have with my mom. Square and square root is kind of like parent and child. Now, the notation that we use to talk about the square root is a little symbol that looks like this, sort of crooked bent line followed by a horizontal line, a little crooked bent line, then horizontal line. So if I wanted to write in symbols the square root of 25, the notation for that would be this crooked symbol here with 25 underneath it. The square root of 25, the notation for that would be this symbol with 25 underneath it. Or if I wanted to say the square root of 4, I would write square root with 4 underneath it. So let's practice using that notation and calculating a couple of square roots. Someone says to me, what is the square root of 16? I'm going to look in my times table for a number which becomes 16 when you square it. And it looks like 4 becomes 16 when you multiply 4 by itself. So the square root of 16 would be the number 4. I could say, what is the square root of 25? So looking in the table, what number becomes 25 when you multiply it by itself? 5 times 5 becomes 25. Therefore, the square root of 25 is that original 5. Or I could say, what is the square root of 100? Looking for a number which becomes 100 when you multiply it by itself. If I multiply 10 by itself, 100 results. So the square root of 100 is 10. The square root of 1, for example, if I'm asking myself what number becomes 1 when you multiply it by itself, if I multiply 1 by itself, 1 times 1 definitely results in 1. So 1 is equal to its own square root. And I could say, what is the square root of 0? What number becomes 0 when you multiply it by itself? Well, I think 0 times 0 results in 0, right? If you multiply 0 by anything, 0 is always what results from that. So 0 squared must result in 0. And so 0 is also special. 0 is also equal to its own square root. Now, the square roots that we've done so far have all been nice enough that they've shown up on a times table, and the answers to those square root questions have been nice whole numbers. But if I ask you, for example, for the square root of 5, and if I look on my times table for an entry of 5 on the diagonal, I do not see an entry called 5 on the diagonal of my times table. And this is an indication that the square root of 5 is not going to be a nice whole number. So I am going to use a calculator to help me to find the square root of 5 in this situation. Now on the Windows 11 calculator, the square root button is right here on the far left side. If I type in 5 and then type in that square root button, I get an answer of about 2.236 if I round it to 3 decimal places. If you want to do the calculation on the graphing calculator, you can also use the square root feature. Now, the square root feature on the graphing calculator is located here in the left column, this tiny blue symbol above the x squared button. If I would like to access this blue symbol, the first thing that I need to do is press the blue button called second. And if I hit the blue button called second, and then I hit this x squared, that'll give me the blue square root symbol above the x squared. Then all I have to do is type 5 underneath that and hit enter, and I get the same result here, 2.236. So as usual, the Texas Instrument calculator and the Windows 10 calculator operate kind of backward. On the Windows calculator, you type in the number first, and then you type what you want to do to it. Whereas in the graphing calculator, you type in the square root first, and then you type in the number. So they're a little bit opposite in that regard. For another example, if someone asked me for the square root of 37, the square root of 37 could be found by just typing in the square root button, typing in 37 and hitting enter on a graphing calculator. So that would be about 3.083 if I rounded this to 3 decimal places.